Okay, so here's the problem that we're going to play with. Before we begin this problem, I want to show you the ultimate rule that's going to come into play with this problem. Or basically the main identity. Sine squared t plus cosine squared t equals 1. And basically what I'm going to try to do here is I'm going to try to figure out if I can rewrite this as a sum of functions with the derivative of one of the functions on the outside. That is to say, I want to use the substitution rule. So for example, if this is not going to be the case here, but if I had something like cosine squared t times sine t dt, right? If I could make this a sum of things like this, then my u would be cosine t, then my du would be negative sine t dt, and I could manipulate this to get that integral done. Okay? Okay. And so here, this cosine to the 4 of t, let me see here. I can write that. If you look over here, let me see here. Is it better for me to write the sine or the cosine? 0 to pi, okay. Well, let's try it with the cosine squared of t. I can subtract the sine squared t to the other side. 1 minus sine squared t. Okay. I got it. Okay, I got it now. And by the way, so these problems, you have to be a little bit creative sometimes, because it's not going to work out always the way you imagined originally. You have to try different things. But I know that sine squared t is going to be 1 minus cosine squared t, right? So this is actually quite interesting here. Let me see here. What else can I do here? So what if, so let's try this out. What if I did this? What if I did 1 minus cosine squared t, then cosine to the 4t dt, integral from 0 to pi. Okay, like this. So then I can distribute and I get from 0 to pi cosine to the 4t minus cosine to the 6t dt. Okay. And of course this, I can write this as the integral from 0 to pi of cosine to the 4th of t minus the integral from 0 to pi of the cosine of 6t dt. Okay. 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 Yes. So now here we're gonna do a kind of trick here. What we're gonna do is, we know that the cosine squared of x is equal to 1 plus cosine of 2x over 2. And we know that the sine squared of x is equal to 1 minus the cosine of 2x over 2. Okay, so these identities are good to have memorized. The cosine squared x is 1 plus cosine 2x over 2. And so I can rewrite this integral over here. The integral from 0 to pi of cosine to the 4th t dt. Well, that's the same thing as the integral from 0 to pi of 1 plus cosine of 2x over 2 squared dt. Why squared? Because this is cosine to the 4, cosine squared is cosine to the 4th. And now here I can start, this I'm going to have to FOIL it out, right? So if I FOIL it out, I'm going to get 1/2 times 1/2, which is 1/4. And then, yeah, let me show that to you over here, what I'm doing. 1 plus cosine of 2x over 2 times 1 plus cosine of 2x over 2 equals, like, and essentially 1 times 1 is 1, and 2 times 2 is 4, so that's why it's 1/4. I can see it as, and then 1/2 times cosine 2x over 2 will be 1/4 cosine 2x, that's a plus, and then plus that, so it'll be plus essentially 1/2 cosine of 2x. And then here it will be plus, let me see here, 1/2 cosine of 2x plus 1/2 cosine of 2x, which is going to be plus 1/4 cosine squared of 2x. Okay? Okay. So that is, yeah, so 1/4 plus 1/2 cosine of 2x, and then plus 1/4 cosine squared of 2x dx. Okay. Okay. So now I'm gonna have to use the same rule here to break this cosine squared 2x into a sum of cosines that's more manageable. Okay, so let me write that over here. So this is going to be the integral from 0 to pi, open bracket, 1/4 plus 1/2 cosine of 2x plus 1/4, open bracket, and what is this? This is going to be 1 plus the cosine of what is 2 times 2x? 4x over 2, and then close bracket, and then dx. And let me just double check my my formula here before I give you this formula all fucked up and shit. Okay. Ah, yes. Cosine squared x is 1 plus cosine 2x over 2. Yes, exactly. Yes, exactly. So now everything I've done so far is good, and now here we're finally getting to the main event. Here, this is gonna be 1/4 times the integral from 0 to pi dx plus 1/2 the integral from 0 to pi cosine of 2x plus 1/4 times 1/2 is 1/8, right? So that's going to be the integral 1/8, the integral of 0 to pi of dx, just dx, right? And then plus 1/8 the integral from 0 to pi of the cosine of 4x dx. Okay, So yes, let me continue down here. So I know that the integral of 0 to pi dx is going to be equal to 1 over 4, and this is going to become x, so then it'll be x evaluated from 0 to pi, and then plus 1/2 this integral. I'm about to show you on the side how I get what I'm about to get, but it's going to be sine of 2x divided by 2 evaluated from 0 to pi. Now let me show you how I got that. Okay, this is going to be a brief aside for this part. Okay, do I want to erase that? Yeah, let me erase that. Okay, so how did I do that integral? Okay, the integral of sine, the integral of cosine 2x, okay, dx. Okay, so what I'm going to do is I'm going to let u equal to 2x, then my du is equal to 2 dx, and so therefore I divide both sides by 1/2 and I get 1/2 du equals dx. Therefore I can rewrite this integral in terms of u as the integral of the sine of u times what is dx? 1/2 of du. And I know that the integral, not sine u, sorry about that, cosine u. I know that the integral of cosine is the sine of u, and the 1/2 came out, so it's 1/2 sine u. And I know that it's sine u because when I take the derivative of the sine, I get the cosine, right? Okay. And then I finally just plug back in what my u is, which is 2x. So that gives me sine of 2x over 2. And so that's how I did that integral right there. Okay? Yes. And then here I'm going to get plus 1 over 8 x evaluated from 0 to pi. And then finally I'm going to get plus 1 over 8, and then using the same technique as that, except that instead of 2x it's 4x, I get that this is going to be sine of 4x over 4 evaluated from 0 to pi. And then finally, if you look at here, let me see, can you see this? Yeah. If you look at this part, 1/4, the x evaluated at pi minus 0 will be pi minus 0, which will just be pi. So here I get 1/4 pi. Now here, sine of 2 pi will be 0. Sine of 0 will be 0. So this term goes away, plus 0. This becomes plus 1/8 pi. And then this term, sine of 4 pi is 0. Sine of 0 is 0. So this also goes to 0. So I'm left with 1/4 pi plus 1/8 pi, which will be, let me see, this will be 2/8 pi plus 8 pi, so 3/8 pi. So this first integral we just evaluated is 3/8 pi. Okay. And now we have to calculate this one. Now because that has a cosine to the 6th power, we're gonna have to do a little bit more. We're gonna have to do a little more finagling like we did here, because instead of raising it to the square power, we're gonna raise it to the cube power. Okay. And so, in order to effectuate that more carefully, what I'm going to do is I'm going to oh my god, I don't want to erase. Okay, I'm gonna have to erase. I'm going to copy this cosine squared formula up here at the top, and I'm going to try to do this calculation in as clean a manner as possible without erasing the other calculation I did, so that you can follow along as carefully as well as you possibly can. Okay. Okay. And so now, okay, so now that this calculation has been performed, let me photograph this so far. Sorry about this, I'm taking some photos of this. Hello, just wanted to let you know the problem is in process. Okay. So now, okay. And of course, this result here, I want to commemoralize it over here for you because we're going to see it come up again. And it is that the integral of the cosine, let me generalize, instead of 2x, let's call it a times x, will be equal to the sine of ax over a plus some integration constant c. We didn't see the c here because we knew that because it was a definite integral, the c would cancel out when we evaluated at the upper and lower endpoints of integration. Okay. But that way we don't have to do this integration again. We can just use this result. And of course this, although it's not a formal proof, you can see that you could formalize this into a proof. Yes. Okay. So now what I'm going to do, because again, so what we're going to try to do is we're going to try to get the integral of cosine to the 6th power. So I'm going to do this instead to the cube. So I'm going to start foiling it out. Here I already have it to the 4th power. So I can start by multiplying this by that to get it. Okay? But wait, should I do that or should I just do it all? Yeah. Okay. Okay, no. What I'm going to do here is I'm going to try and clean up this calculation as much as possible because I want to be able to use the board because this is going to get ugly. Okay, I didn't want to do this, but we're going to have to. Okay. Okay. So we already saw this, we already saw this, we already saw this. So what I'm going to do is I'm just going to copy this part. The integral from 0 to pi of sine squared t cosine to the 4th t dt. We saw, I'm going to cut through all this bullshit and I'm going to write that down there, which is the integral from 0 to pi of cosine to the 4th t dt minus cosine to the 6th of t dt. Right? And then we already saw that this first integral is 3/8 pi. Right? And then we don't know what this integral yet. So what I'm going to do is I'm going to erase all this now, and we're going to use all this space to get this integral done properly. Yes. Okay. 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 I put the minus sign because we're going to have a minus and whatever this integral becomes. Now, I want to calculate what is the cosine of 6t. From using our formulation over there, we know that this is going to be equal to 1 plus cosine of 2x over 2 to the cubed power. Now, I'm going to do something that I could have done in the previous step when I was squaring it, but I didn't because I didn't feel it was strictly necessary and because it wasn't too complicated. But here, what I'm about to do is going to help us out a lot. So I can look at, obviously, what does this mean? This means 1 plus cosine of 2x over 2 times 1 plus cosine of 2x over 2 times 1 plus cosine of 2x over 2. Okay. Now, if you notice, how do you call it? The denominator is going to be 2 times 2 times 2, which is 8. I can just pull that out to the front, and I can have 1 plus cosine of 2x times 1 plus cosine of 2x times 1 plus cosine of 2x. Okay? Okay. Now, this is going to be easier to FOIL out. Now, I hasten to add here, when I have this thing like this, anyone who wants to be anyone who would like to could use the Pascal Triangle, and it could save a lot of headache. Or you could do it longhand, and I'm going to do it longhand, but I just wanted to point out, if you wanted to, I could show you how to do it with the Pascal Triangle. Like if this was to the, you know, some like 10th power, and we wanted to find out what one term was, we could use the Pascal Triangle. Okay. But anyway, so here, this becomes, I'm going to do these two first, and I'm going to bring down this one so I don't forget it. It's going to be 1 times 1, which is 1. And then 1 times this plus 1 times that will be plus 2 cosine of 2x. And then finally plus cosine squared of 2x. Right? Okay. And then I'm going to FOIL these two together. So I'm going to get 1 over 8. 1 times that is going to be 1 plus cosine of 2x. Plus, 1 times that times 1 times that. Okay, then plus this times that, which is 2 cosine of 2x. And then plus 2 cosine squared of 2x, because I'm multiplying these two. Then finally I'm moving to this term, plus cosine squared of 2x, because I'm multiplying that. And then I'm going to multiply this, plus cosine cubed of 2x. Okay? Okay, and then this simplifies to 1 over 8 times 1 plus 3 cosine 2x plus 3 cosine squared 2x plus cosine cubed 2x. Okay? Okay. Okay? And so now, in order to help us out with this integration, I'm going to get rid of all this, and I'm just going to get this result here. So, over here, I want you to remember what we just did here. We got that the cosine of cosine to the 6th power t is equal to 1 plus cosine of 2x over 2 cubed. And we saw that that gave us 1 over 8, open bracket, 1 plus 3 cosine of 2x plus 3 cosine squared of 2x plus cosine cubed 2x. Okay? So, I hate when I have to like break up a calculation like this into so many steps, but I'm going to have to erase this so we can move on to the next step, so I don't like fucking crush it all into the sheet. And I honestly don't think I could do that unless I was using a miniature pen, and unless you guys couldn't see it anymore, and that would not be acceptable. I mean, that would violate the whole purpose of me making this video. Okay. I must confess that I'm extremely tempted. Well, fuck it. I'm just going to show you anyway. How could I have done that with the Pascal Triangle? Well, let's say I had done the 1 plus cosine of 2x. I'm just going to do this real quickly. Let's say this was cubed. Is it cubed? It's cubed. Yeah, of course it's cubed, right? Remember, the 1/8 I already pulled out in the previous calculation, right? So I would make my Pascal Triangle. And if you notice this is when you have a binomial to the 0th power. Anything to the 0 is 1. That's why that makes sense. A binomial to the 1st power, like let's say a plus b to the 1st power. Of course, the coefficients are going to be 1, because it's going to be 1 times a plus 1 times b. A plus b to the square power will be a squared plus 2ab plus b squared. And then here, how would I use this here? Well, this will be our coefficient for the first one. 1 times 1 to the 3rd power cosine of 2x to the 0 power plus 3, what I want you to realize here is that the power of the first term goes down by 1 each time that the power of the second term goes up by 1, okay? And then plus 3 plus 1 and if you notice, using the Pascal Triangle, I was able to do this very rapidly. And if you simplify it, you'll see cosine of 2x to the 0 power will just be 1. 1 cubed is 1. 1 times that first term is exactly just 1. This second term will be 1 squared is 1. Cosine to the 2x to the 1 is just cosine of 2x times 3. That's exactly that. And you can convince yourself in a moment that these two final terms also exactly match these two terms. So the Pascal Triangle, aka the binomial theorem, or also it was also known to the Chinese, like I think in the 9th century, long before Pascal was born. But I couldn't help bringing that in as like a nice way that you could avoid a lot of the algebraic ugliness. But you know, some of us like to suffer. Nah, I'm just kidding. Okay, but anyway, so now we're gonna move on to the actual calculation of this integral before like the whole brain melts, and then and then like that's not good if my brain melts. Okay. Okay. So now the integral of cosine to the 6 fuck it, we'll call it cosine to 6 dx is going to equal to 1/8 times the integral from 0 to pi. This is of course from 0 to pi of this thing of 1 plus 3 cosine 2x plus 3 cosine squared of 2x plus cosine cubed 2x, and then all of that dx. Okay. Okay. So now, what I want you to realize is that I can break this up. This is going to be 1/8 times the integral of 1 dx from 0 to pi plus 3/8, because this 3 and that 1/8 become 3/8 times the integral from 0 to pi of cosine of 2x dx plus 3/8 the integral from 0 to pi of cosine squared of 2x dx plus 1/8 the integral from 0 to pi cosine cubed of 2x dx. Okay? Okay. Okay. So now here, this integral, we can already do it. This integral, we can see is just this integral that we already did in the previous example. This integral, we're going to do it using this formula to rewrite this inside, just like we did in the previous integral. And then this one, we're going to get to do something special, and so that's going to be very nice. And so, okay, so now we're on track to do this problem. Okay, this first one. Obviously, this is going to become 1/8. The integral of 1 dx is just going to be x evaluated from 0 to pi. Here, this one we can see is going to be plus 3/8. The cosine of 2x, the integral of that will be sine of 2x over 2. So sine of 2x over 2 evaluated from 0 to pi. What about this one? This is going to be, okay, so I'm going to do that one over here so that it doesn't clutter the main line of our argument over there. Okay, so the integral from 0 to pi cosine squared 2x dx will equal to the integral from 0 to pi of 1 plus cosine of 4x over 2 dx. And I want you all to realize that I got that straight from that formula at the top. Cosine squared of x is 1 plus cosine of 2x divided by 2. In our case, the cosine squared of 2x, so what is the 2x and the cosine on the top in the numerator? It's cosine of 2 times 2x, which becomes the 4x here. Okay? And then this breaks up into the integral from 0 to pi of 1/2. So 1/2 dx plus 1/2 integral 0 to pi of the cosine of 4x dx. Okay? We can see that this becomes 1/2 x integrated from 0 to pi plus, and then here, that's the same integral we have there. The integral of cosine ax is sine ax over a, right? So it's going to be 1/2 sine of 4x over 4 evaluated from 0 to pi. Now in this case, I'm now in a position to solve this part here. The 1/2 x evaluated from 0 to pi, x evaluated from 0 to pi is going to be pi minus 0, which is just going to be pi. So that's going to be 1/2 pi, or in other words, pi over 2. Now the sine of 4 pi is 0. The sine of 0 is 0. So this whole term disappears. And so this integral, the integral squared of 2x dx is pi over 2. So that's going to be plus 3/8 times pi over 2. Right? Because, yeah. Then finally, we're going to concern ourselves with this integral, this final integral. Okay. Okay. Now, this final integral, I'm going to do it here on the bottom because this integral deserves our careful attention, and I want to remind you, bye Juan! I want to remind you that the sine squared of x plus the cosine squared of x equals 1, and therefore, for our case, we can see that the cosine squared of x equals 1 minus the sine squared of x. Okay? Okay. So, okay. Let me see here. Okay. So, let me do that here. The integral from 0 to pi of the cosine cubed 2x dx is going to equal the integral from 0 to pi of, let me see here, of the cosine squared of 2x times the cosine of 2x dx. Now, if you notice, I'm doing this, I'm breaking this up like this because I'm going to rewrite the cosine squared in terms of the sine. The sine, what's the derivative of sine? Cosine. So this is going to be set up exactly for the substitution, for the integration by substitution. And this is a classic technique for doing cubic powers. This is what I originally thought I was going to have to do when I first saw this problem. And so that's why I was off base for a few moments. But then once everything else came together, it was easier. Okay, so now here, I'm going to replace the cosine squared of 2x. So this is going to be 0 to pi of the 1 minus sine squared of 2x cosine 2x dx. Now, I must confess to you that these trigonometric integrals, they can get really long. But I want you to also notice that I'm just using the same simple tools over and over again. Okay? I mean, they're not that simple, but they're not that hard. In other words, what I want you to notice is that even though this problem looks like it's fucking monstrous and that it's long and everything, it's actually the same procedure occurring over and over again. Okay, so now we're gonna distribute this cosine 2x in here. Okay. So I guess let me continue this calculation down here so that we can have some room and so we don't I don't want to lose the flow of this calculation. So this is going to be the integral from 0 to pi of the cosine of 2x minus, and let's say dx here, the integral from 0 to pi of the sine squared of 2x cosine of 2x dx. Okay? Yes. And so now we're in a position to solve this problem. Okay, so this first part is already clear to us because that's just the example up there. That's going to be, yeah. Okay. So this first piece is going to be sine of 2x over 2 evaluated at the top and at the bottom, right? But of course, we've already seen from the previous cases that that's going to be 0. Yeah, so this is gone, okay? Let me briefly remind you that that goes away. Man, I'm going to have to clear up more of this board so we can do this properly. This one, oh no, this is the main calculation we're trying to do, okay. Okay, that's the main part we don't want to get rid of. This is gone already. Is it gone? Yes. Okay. So what I'm going to do now, even though I don't want to do it, is because I want to focus on this integral a little more. I'm going to erase that, and I'm going to put the integral from 0 to pi cosine 6x dx, and I'm going to put what I've gotten to over here equals 1/8 x evaluated from pi to 0. That's 1/8 of pi, so pi over 8, plus, now this part went to 0, right? Sine of 2 pi is 0, sine of 0 is 0, so that's gone. Then this plus 3 pi over 16. And then we're just missing this part, right? Okay, so plus the missing part here that we're solving for right now. Okay. So yes, as much as I don't want to do this, I'm going to erase all this now so we can have more room to do this integral. Okay, so where I last left off, 0 to pi cosine cubed 2x dx. Equals the integral from 0 to pi cosine of 2x dx minus the integral from 0 to pi sine squared 2x cosine of 2x dx. Okay, so now I'm going to get rid of all this. Okay. Wow, this is long. Okay, so now this one, like we said before, because of what I just erased, becomes sine of 2x over 2 evaluated from 0 to pi, and that's going to go to 0, minus whatever this becomes, integral from 0 to pi sine squared of 2x cosine of 2x dx. Okay, so here's where the magic happens. The magic happens when, so first of all, I'm going to make a little aside, and I'm just going to focus on this part here. The integral, so aside. From 0 to pi sine squared 2x cosine of 2x dx. Let u equal to the sine of 2x. Okay? Then my du, the derivative of this, is going to be cosine of 2x times the derivative inside, which is 2 dx. Okay? And if you notice, I have the cosine of 2 dx here. So 1/2 du will be exactly cosine of 2x dx. Okay, that's going to be my du. That's going to be my u. Now, what is my u evaluated at 0? The sine of 0 is going to be 0. What is my u evaluated at pi? Sine of 2 pi. That's 0 also. Aha! So this integral, actually, it's going to be the integral from 0 to 0 of u squared 1/2 du. But because of the properties of integrals, if you have the same lower limit and upper limit, it zeroes out. So this whole integral goes to 0. Yes. Because this one goes to 0. That one we just chose goes to 0. So this term actually goes to 0. And so we can finally conclude that the integral from 0 to pi of cosine to the 6x dx is going to be, let me see, pi over 8 plus 3 pi over 16 is 2 pi over 16 plus 3 is 5 pi over 16. So it's 3 over 8 pi minus 5 pi over 16, which is going to be 6 pi over 16 minus 5 pi over 16 is just pi over 16. And that finally is our answer. Ta-da!